Hey everyone, long time no see. I want to give you a quick update on the board for the electronic screwdriver. You can find the schematics on the Hackaday page. I will link it below. This video is sponsored by PCBWay. They manufacture the board, source and assemble the component. So far, I'm really pleased how everything turned out. The process is straightforward. You need to prepare Gerber files, BOM and component position files. Then just submit your order and you'll be set. In my case, there was a little bit of a communication going back and forward. I have chosen a component with the wrong footprint, but they caught it and sorted everything out pretty quickly. So thanks again to PCBWay for making these beautiful boards. As you can see, I've soldered a motor and leads for the battery to show you how everything works. But first, let's go through each component one by one. In the back, here you can see a Type-C USB connector. It still runs only on 5 volt, but I chose it because I think it's much better connector than mini USB, and also the whole world is switching to USB Type-C anyway. On the other side you can see an LED, and then is the charger IC. The LED will show if the battery is charging or not. Down here we have the battery protection. I need to give a shout out to Noah Tolman, who pointed out that the under voltage protection needs to be no lower than 3 volts, so I fixed everything up with this revision of the board. Next is the boost converter that brings the battery voltage up to 6.5 volts required by the motor. And finally, here is the user input and also the signal conditioning. Let's hook everything up. At first, nothing happens. The protection IC will keep the battery disconnected until we plug in the charger. After we plug in the cable, we see that the motor is spinning, and we disconnect the cable and it's still going. Someone pointed out in a comment that we need a button to lock the shaft in case we need to use the screwdriver in a manual mode. If you look at the driver's datasheet, there is a table that shows output of the AC for any given input. With the input conditioning circuit I made, it's such that if no buttons are pressed, the motor is in a brake condition. And you can see now that the motor isn't spinning. And if we push both of the buttons, then the shaft can spin freely. This has its drawbacks, since in this state the motor is in brake condition if we don't use the screwdriver at all. This means that it draws about 1 milliamp. In 2 weeks the battery will go flat. If we are using a screwdriver every day, that might not be a problem since we are going to charge it anyway. Another workaround would be to make a docking station, so the battery charges all the time. A third and final and how to say, the fanciest way of dealing with it is to put some kind of a micro such as the PIC12C5 to implement an algorithm to switch everything off if the tool is not in use, let's say for a 5 minute. And if we want to be really over engineering, we can add an accelerometer like in this soldering iron. It will detect when the user puts down the soldering iron and will lower the temperature, and when we pick it up it will get hotter so we can work with it. This is the quick update from my side. Please tell me what you think in the comments below. Thank you for everyone who has subscribed, and see you in the next time. Bye. And if you learn soldering from memes, you know that this is how you solder and this is how you handle a soldering iron.